A stone is thrown up at a velocity of 50 meters per second. Half a second later, a second stone is thrown up also at a velocity of 50 meters per second. At what time and height do the stones pass each other? So with this question, we know that the initial velocity is 50 meters per second, and we also know that the acceleration is gravity, so it's just negative 9.8 meters per second squared. We also know that the velocity at the top is 0 meters per second, and the displacement at the end is 0 meters for this curve. So for the rest of the numbers, we're going to have to do math to figure this out. And the first number we're going to figure out is the time at the top. And we're going to be using the equation final velocity minus initial velocity over acceleration is equal to time. So the final velocity we know is 0 because it's at the top. And then the initial velocity is 50. And we're going to put that over the acceleration, which is negative 9.8. And when you put that in the calculator, we should get 5.10 seconds. Yep. So we're going to use that time that we just found, and we're going to find the displacement at the top as well. So we got our displacement equation that we plugged in the time for. So it's for the initial velocity times time plus 1/2 acceleration time squared. So we have 50 times the time, 510, plus 1/2, negative 9.8 times 510, 510 time squared. So what we should get for this first half is 255, and for the second half we should get negative 127.5. So I'm going to type that in, and yes, we get 255, and we get, yep, all right, so those numbers are correct, and when you subtract them, you just get 127.5, which you should notice is half of 255. And now with these, we know that the time, since we know the time at the top is 510, we could double it and get the time at the bottom is 1020. And we also know since the initial velocity at the start is 50, the velocity at the end should be negative 50. And now with these, we're going to find the second stone, which the initial velocity once again is 50, and the acceleration once again is negative 9.8 meters per second squared for gravity. Only this time the stone is thrown 0.5 seconds afterwards, so our time is just going to be the time for the first stone plus 0.5 seconds. And once again, we know that the velocity at the top is 0 meters per second, and displacement is 0 meters. So we're going to do math to figure out the rest of these numbers. And the first thing we're going to figure out is the time, which is pretty simple. All we have to do is add half a second to figure out when it's thrown. So it's going to be 5.6 seconds, because that's the top, and plus half second. So with this time, we're going to do the same thing, and we're going to plug it into the displacement equation. And we got 50 for the initial, the time, 560, 1/2, negative 9.8, which is the acceleration, and then 560 and 560 is the time. So we're going to plug that into the equation. We're going to get 280 minus 153, which should come out. Yep, so we got 280, and then you have negative 153, yeah. So when you subtract that, you get 126. And then with this information, we can go back up here, and we could find out that the time is double once again, so it's 11.2 seconds. And the initial velocity is opposite once again, so it's negative 50 meters per second. So now we have all the numbers for both of the stones, stone 1 and stone 2. So we could go down here and we could figure out when and where they pass. So what we're going to do is we're going to set the two displacement equations that we just did, and we're going to set them equal to each other. And what we're going to do is we are going to get 50t plus 1/2 negative 9.8 t squared is equal to 50t plus 0.5 plus 1/2 negative 9.8 plus t.5 plus 0.5 squared. So a lot of these numbers can cancel, so we should be left with t plus t squared is equal to t plus 0.5 t plus 0.5 squared, because the 50s are going to cancel and the 1/2 negative 9.8 are going to cancel. So what we're going to be left with is t to the third is equal to t to the third plus 1.125. And when you take the cube root of both sides, you should get 0.5 seconds for the time. So when they pass is at half a second. So now we're going to find the displacement. So we found the when, now we're going to find the where. So the where, we're going to do displacement is equal to the two equations added to each other. So when we do the equation, we just get the same thing, and only we plug in the 5.5 seconds for the time. And I'm not going to read all that because that's a lot. So when you do that all the math out, you get 68.875 meters. And that is when and where the stones pass when you throw them up at initial velocity. And we found all the numbers for stone 1, at the top of the end, and we found all the numbers for stone 2 at the top and the end.